Last year, astronomers spotted an explosion a trillion times brighter than the Sun that they dubbed the brightest supernova ever seen. But that massive explosion of light which outshone the whole Milky Way wasn't a supernova at all, but a supermassive black hole. According to a new study, the black hole was in the process of shredding a distant star that wanted to close, creating an incredible amount of light. The team of researchers was led by Dr. Giros Lilitas at the Weizmann Institute of Science in Israel and the Dark Cosmology Center in Denmark. The observations were made as part of the All-Sky Automated Survey for Supernovae. Dr. Lilitas said, "We observed the source for 10 months following the event and have concluded that the explanation is unlikely to lie with an extraordinarily bright supernova. Our results indicate that the event was probably caused by a rapidly spinning supermassive black hole as it destroyed a low-mass star. The extreme gravitational forces of the supermassive black hole located in the center of the host galaxy ripped the Sun-like star apart when it came too close to it. The event, which is called a tidal disruption event, occurs when stars get too close to a black hole's event horizon, the boundary within which nothing is able to escape its gravitational pull. Tidal disruption events have only been observed 10 times before. In the process of the star being destroyed, it was spaghettified, a process where objects are vertically stretched and horizontally compressed into long thin shapes, much like spaghetti. The colliding debris approaching the hole, as well as the heat generated from the debris coming together to form larger bodies, led to a burst of light. The bright light made the black hole event appear to be a supernova, even though that specific star could not have become a supernova as its mass was too small. Morgan Fraser from the University of Cambridge said, "There are several independent aspects to the observations that suggest that this event was indeed a tidal disruption and not a superluminous supernova." The team observed the events using telescopes on Earth and in space. Two of the telescopes used, the Very Large Telescope and the New Technology Telescope, are based in Chile and run by the European Southern Observatory. One of the other telescopes used was the NASA European Space Agency Hubble Space Telescope, which is in low orbit of the Earth. The data shows that the event went through 3 distinct phases over the 10 months of follow-up observations and more closely resemble what is expected for a tidal disruption rather than a superluminous supernova. The scientists observed an overall rebrightening in ultraviolet light as well as a temperature increase, further reducing the likelihood of a supernova event. The location of the event was also strange. It took place in a red, massive and passive galaxy, which is not the usual location for a superluminous supernova explosion. These normally occur in blue, star-forming dwarf galaxies. Although the team say a supernova source is very unlikely, they also say that a classical tidal disruption event would not be an adequate explanation for the event either. Research team member Nicholas Stone from Columbia University said, "The tidal disruption event we propose cannot be explained with a non-spinning supermassive black hole. We argue that ASASSN 15LH was a tidal disruption event arising from a very particular kind of black hole. The mass of the host galaxy suggests that the supermassive black hole at its center has a mass of at least 100 million times that of the Sun. A black hole of this mass would normally be unable to disrupt stars outside of its event horizon. However, if the black hole is a particular kind that happens to be rapidly spinning, a Kerr black hole, then it could disrupt those stars. Even with all the collected data, we cannot say with 100% certainty that the ASASSN 15LH event was a tidal disruption event," said Dr. Lilitas.